Is on the major sources of energy. All right. Now, a lot of this stuff is old stuff you've done in grade 8 and grade 9, so just bear with me. First of all, where do we get our energy from? Okay. What are our sources of energy? What are our sources? Where do we get them from? The sun is the source of energy. Wind is the source of energy. Flowing water is a source of energy. All right. In general, people, this is nothing new. We can put fuels, our energy sources, into two basic categories. The one considered to be renewable, the other one non-renewable. The non-renewable sources, people, you should know at this point, we use them up faster than what the processes can produce them. Okay. Renewable sources are sources that can be replenished or replaced in a moderate period of time in general within our lifetime. Okay, sometimes shorter, sometimes every 3 months or 6 months it can be replaced. The renewable sources, solar energy, water energy, wind energy, wood, burning of wood, geothermal, and tidal. Now the ones we use in Namibia, sun and water. In general, in Namibia, we use a lot of sun for heating water in a solar geyser. Okay, many houses have a solar geyser. And then lots of places have put up solar panels. When you drive around in Windhoek, you can see the solar panels on the roof. Yeah? Replenished is replaced. Okay. If you replenish your energy supplies, you eat a bar of chocolate and you drink a tin of Coke and you have a hamburger. Okay, then you've replenished your body's energy supplies. All right. So the renewable sources can be replenished, can be replaced in our lifetime or in a short period of time. Non-renewable can't. People, where in Namibia do we use water energy? Yes, Ruakana, the hydroelectric power station, generates electricity from water that falls down a waterfall driving a turbine. Yes. We use a little bit of wind in the form of wind pumps, but we don't generate electricity on a large scale in Namibia with wind generators. Maybe in Ludwitz one could put up a wind power station because there's lots of wind. But here in Otjiwarongo, do we have a lot of wind? No. Geothermal, we have a little bit of hot water springs near Grasbarmen, but we don't really use it on a large scale to generate electricity. There are some places where they use the steam that shoots up from the cracks in the earth to drive turbines to generate electricity. They build communal kitchens over these sources, and they use the steam to cook food with. All right, Hawaiian Islands. Okay, So it can be used. Tidal energy, we don't use it around here. I think some of the European countries along the coast, they might use a bit of tidal energy. They've got large buoys in the ocean that lifts up and down together with the movement of the waves. Or they build dams when it's high water, the water flows into the dam. And then there's an opening with a propeller that drives a turbine. When the tide goes down, the water runs out of this dam and it drives a turbine, generating electricity. So as the tide comes in, turns in the one way, tide goes out, goes in the other way, generates electricity. There's continuous movement. All right. Although I think it's more difficult to harness tidal energy than any of the others. Okay. The non-renewable sources, people in general, the fossil fuels are non-renewable. Coal, oil, natural gas. People, even uranium, even though we only use a very tiny amount of uranium in a nuclear power reactor, the uranium supplies are not infinite. All right. So it is actually not so very renewable. Some sources classify it as renewable, but you can argue it a bit both ways. Now, the next one. When we're going to have a look at the renewable and the non-renewable sources, the renewable sources, what are the advantages? Well, they will never be used up. We will always have some form of energy. There will always be wind. Say again? Okay. There will always be wind. There will always be, well, water flowing in rivers. There will always be wave motion because of the attraction of the moon, the gravitational fields, etc. These sources usually have no pollution in the form of greenhouse gases, mainly carbon dioxide. All right? The maintenance, they say, is not too expensive, but that is also relative. But okay, it's not impossible to do. If we're going to have a look at the disadvantages of the renewable sources, then we will see the renewable energy is spread over large areas. For example, if I want to have a solar plant with solar panels, I need a very large surface area on which I could put the panels. If I go outside here in the cities, how do they solve that problem? They put the panels on the roofs of the buildings. All right. But we still require a fairly large surface area to generate a little bit of solar energy. The technology to harness the energy is not fully developed. People, I think, if we go and look at solar panels and their costs and their efficiency in terms of the last 10 years, the new solar panels can do much more than what the initial ones could do. All right. They can generate greater amounts of electricity. Yes. The sources are not always available. I think 50 years ago in Namibia, I don't know if there were many solar panels, and I think Europe already had solar panels. Okay. It takes some time for things to become available. There must be a demand, and it is a process. So sometimes it's not always available. And then lastly, even though there's no pollution, there is always some environmental consequence. For example, at Ruakana, if they dam up the water at the top of the waterfall, the part of the river below the waterfall is either going to have less water, or it's going to have more water if they let the water out than what it should have if it was just naturally constantly flowing. So there's always a little bit of ecological damage, but the environment tends to adapt to that better than it does to normal pollution. All right. The fossil fuels, non-renewable sources, what are their advantages? Well, they are fairly concentrated sources, and they can release a fairly large amount of energy for a small amount of fuel. I can fill up my car's petrol tank, and I can drive around for a month if I don't drive too much, maybe a little bit longer than a month in town. All right. Developed simple technology to harness these sources. Very basically, most of these sources have to be burnt, and from that the heat is used to generate electricity, and from that we can convert it to whatever we want with the apparatus that we plug in. The disadvantages of the non-renewable sources, eventually it will be used up. So we are going to reach a point, if we are completely dependent on these sources, we are going to reach a point where there isn't any more. I don't know if you've ever been hungry and gone to a cupboard and opened it up and there's nothing in the cupboard. That's what it's going to come down to. So it's very wise to start looking at alternative sources. And that is why in Namibia, on a fairly large scale, we do use solar panels. And I think in the future, it's going to even become more. Okay. And generally, it causes pollution because most of them have to be burnt. And when we burn hydrocarbon fuels, we get carbon dioxide and water vapor. And together these form the so-called greenhouse gases. Different sources of energy. We can use chemical energy. What is chemical energy? Well, it is a store of chemical potential energy. Where is the energy stored? Within the chemical bonds, in other words, in the covalent bonds when electrons are shared. Within the ionic bonds when opposite charges attract. Okay? That is where the energy lies. So we often have to burn them to release the energy, and any hydrocarbon fuel, when I burn it, it will form carbon dioxide, water, and energy. If there isn't enough oxygen, if there's incomplete combustion, I can get carbon monoxide and carbon forming. All right. Yeah. If you drive around with your car in Windhoek long enough, and at a certain stage, if you pull your finger along the car, then you'll see it's like a blackish, grayish layer on the car. That is from the carbon, among other things, due to incomplete combustion of all the car engines. Potential energy from water. Water is dammed up at Ruakana on the higher part of the river, and then there's a waterfall. It is released. The gravitational potential energy of the water as it falls is converted to kinetic, and then this is used to drive a turbine, and we generate electricity. We can use movement from tides, and this can also then be converted to electrical energy. Geothermal, we don't use much of that around here in Namibia. Grasbarmen, they've built the hot water springs, and at ice, where they use it as a resort for people to go and swim in the hot water. Okay? How does it work? We know that the core of the earth is molten, so it's very hot. And there are cracks in the surface of the earth, and the water goes down these cracks, and it heats the water, and it becomes steam. The steam is forced up through these cracks, and if they build turbines in specific places, it can drive a turbine, which can be used to generate electricity. All right. Hot water from the springs can be used to heat nearby buildings. All right, by piping it through a system of radiators. Water has a very large specific heat capacity. So it can take up a large amount of energy with every 1 degree change in temperature. But then similarly, when water cools down, for every 1 degree drop in temperature, for every 1 kilogram, it gives off 4,200 joules of energy. And that is why water is very useful in a radiator system for heating or for cooling, as in cars. Okay, nuclear energy. We had a look at some of the nuclear reactions just previously. We said we get what is known as the chain reaction. Remember I said we need a uranium bundle of nuclei. We shoot a neutron into it. It becomes unstable. It splits and it shoots out 3 other neutrons which can go smashing into a uranium nucleus, causing them to split. All right. Now, when we talk about nuclear energy, we can work with 2 types of reactions. I said to you the fission, which is splitting, and fusion, which is adding together. If something fuses, it becomes one. All right. So by adding nuclei together or by splitting a nucleus. Now, usually fission, we use large nuclei. Now, if you look on the periodic table, would I be able to split a hydrogen nucleus? Why not? It only has one proton. Would I be able to split a helium nucleus? Well, technically speaking, it's not impossible, but imagine having to hit a particle containing a proton or two protons and two neutrons, trying to get a neutron to smash into that. It would be like trying to hit a coke tin on a 2-kilometer distance with a gun. It's almost impossible. So, the type of nuclei that is used to split is the bigger ones. Uranium, okay, is relatively speaking a large particle. So, large, unstable nucleus splits into two on impact with another particle. This other particle is very often a neutron that is shot into it. It releases a very large amount of energy, which can be calculated with E equals mc squared, because there's a discrepancy in the mass. Okay. When these unstable nuclei do not produce enough energy, they are left as nuclear waste, which is still radioactive and therefore harmful to the environment. I say to you people, this nuclear waste remains, well, radioactive for very often millions of years. Yes. The fusion reaction occurs on the surface of the sun. And what happens is two hydrogen nuclei collide. They smash into each other. And if they smash with enough energy, they fuse. And element number 2 that contains 2 protons is helium. And that is where the helium on the sun comes from the fusion of hydrogen. It forms helium and very large amounts of energy. That is the energy from the sun. Yes? Yes, they reckon, I think if I remember correctly, that like up until now, about 4% of the hydrogen has been used. It's not something we have to worry about. Okay? Yeah. All right. Solar energy is produced by nuclear fusion. Solar energy, sunlight. The energy from the sun, hydrogen and hydrogen that fuses. So solar energy is as a result of nuclear fusion. Hydrogen nuclei join together, it forms helium. There's a mass discrepancy between the two particles if you add them separately, and when they've fused, this difference in mass, if you put it into the equation, it gives you a value of energy. All right. Because this c squared is 3 times 10 to the power 8 raised to the power 2. So it is actually 9 times 10 to the power 16. So it's 9 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you multiply any number with that, you still have a very large amount. You understand? Okay. So solar energy can be used for heating, for photosynthesis, and to generate electricity with so-called photovoltaic cells. When we add lots of photovoltaic cells together, we get what is known as a solar panel. We will stop there.
Today tastes like a Sunday barbecue. And it never tasted this good.
10s. We were busy with the sources of energy. We have to carry on. More or less in the textbooks, they're on page 194, 195. I will carry on here with the notes. So, we said the last period that chemical energy is stored where? Within the chemical bonds. In other words, if it's a covalent bond, between the shared electrons is where the energy lies. In the ionic bond, the attractive force between the ions that hold the particles together, between those particles we get that the chemical energy then is stored. So just simply a fuel is a store of chemical potential energy. All right? The energy is stored within the chemical bonds. And very often the fuels that we use, they will release their energy when we allow them to burn. In general, any hydrocarbon fuel. Now, examples of hydrocarbon fuels are wood, coal, petrol, diesel, paraffin. The gel that you buy, that green gel, is also a hydrocarbon fuel. When they burn, they react with oxygen, they form carbon dioxide, water vapor, and energy. We know a little bit about the energy from water. Ruakana, the water is dammed up on the higher part of the river, and the power station is built below, near the bottom of the waterfall, and the water falls down onto a turbine. It drives the turbine, the movement of the water, which drives a generator, which generates electricity. We can also use the movement of water from tides. There are various ways of doing it. Sometimes with a high tide, they dam the water up in like a pool, and then when the tide goes out, there's a hole in the wall of the pool with a propeller which drives a turbine, which generates electricity, etc. Okay. Geothermal energy, we don't have many sources here. Grossbarmen and ice are hot water supplies or sources for us, geothermal. The water is heated from the hot core of the earth. All right, there are some places where there are cracks in the earth and there's water that is available, and the water goes down these cracks and it goes very close to the core of the earth, becomes hot, it boils, and it shoots up as steam. Okay, that is geothermal energy, and that steam then can be used to drive a turbine to generate electricity, or it can be used directly to heat buildings or to cook food. Nuclear energy, we've already had a look at that. Fission and fusion, two ways in which we can harness nuclear energy: by making two nuclei fuse together like the surface of the sun. Hydrogen and hydrogen collide. They form helium, and it gives off large amounts of energy. Fission, we said, large nuclei like uranium are split. Okay, don't want to say much more about that. We've done that. Just fission and fusion. Fusion, they fuse together. Fission, we split the nucleus. Solar energy on the sun is nuclear fusion, where hydrogen fuses with hydrogen. We've already said that. The energy, there's a mass discrepancy before the fusion and after the fusion, and that mass discrepancy is multiplied by the square of the speed of light. And I said to you, the speed of light is 3 times 10 to the power 8, so the square is 9 times 10 to the power 16. I think if you multiply anything with 9 times 10 to the power 16, you get a very large number. Okay, so that is where the energy of a nuclear reaction lies in. Solar energy, we can use it directly for heating. Many of our houses have solar geysers. It's a panel connected to the geyser through which there are different ways the water is heated by the heat from the sun through the panel, okay, stored in the geyser. Plants photosynthesize. You've done this grade 7, 8, 9, all right, 10. What do plants do? They carbon dioxide, water vapor, in the presence of chlorophyll, and they need sunlight. In other words, photosynthesis is endothermic. All right, they release sugars and oxygen. Solar energy can also be used to generate electricity. I think in Namibia that is very widely used. We have solar panels, it's a specially made solar panel that converts sunlight into electrical energy with the use of something known as a photovoltaic cell. And a little bit later on we will have a look at how they work. All right. A group of photovoltaic cells is called a solar panel. I think these things are put together, the photovoltaic cells are put together in a solar panel so that one solar panel can supply so much. All right. And then they use that to work it out. I think it's a standard amount that they put into a solar panel. All right. Wind energy, we use that, people, farms to pump water, wind pump. All right. Sailboats, wind-powered generators. More and more when you drive up from Cape Town, not from Cape Town, from South Africa, and you go past Uppington, just before Uppington, on the South African side, not coming from Namibia, there is a wind farm. All right, where they generate electricity with wind-powered mills. All right. The importance of renewable energy. Why is it important? What are we using mainly nowadays? Fossil fuels. Are fossil fuels renewable? No. So why is it important to know something about renewable sources of energy? Well, somewhere along the line, if we keep on using only fossil fuels, it's going to run out. Already, the countries that have oil, they have sort of got the world in an economic grip because they control the price of the oil. And it goes up and down as they see fit. All right. So we should try and find other sources of energy. Renewable sources that we use. We want to reduce our dependency on fossil fuels. And then another one that is fairly important, they talk about a carbon footprint. All right. It's got, among other things, to do with the greenhouse gases that are released, contributing to global warming. All right. Hydroelectric power generation. Yeah, I've just got a very rough scheme of it. What it basically comes down to, water is dammed up on one point. All right. And it's usually in a river, and it's usually at a naturally high point in the river, after which there should be some kind of a waterfall. And then sluices can be opened and closed, depending on what the demand is for electricity. If they open up the sluice, the water simply falls due to gravity down a chute onto a turbine over there. The turbine has propellers which will be driven around and around by the falling water or the moving water, drives a generator which generates electricity. Now when we do the section on electricity, we will have a look at how the generator functions. At this point, it's enough to say the turbine drives the generator, and the moment the generator can move, it will generate electricity, and the electricity is fed into the grid over here via a system of transformers and then to the different cities. But we will have a look at that when we do electricity. Here's a schematic of a wind generator. Now, people, these things are very big. They're very high. The propellers are very large. In general, it seems as if they turn very slowly, okay? But it's because there has to be a certain amount of thrust, and it's actually quite complicated. But very basically, a wind power generator has blades, okay, that catch the wind. They are tilted to a certain angle, and the wind blows against them, and it causes the propellers to turn.